We'd like to talk for a few minutes about firewall policy and the step-by-step development of a firewall policy, and then how to write an IP table script, how to get the script, and how to put the script on the Linux machine. Well, we'll look at the objectives of this to discuss the IP tables paths, the paths that the packets can go. There are basically three places they can go: across the firewall, they can go to the firewall, or they can come from the firewall. And we'll look at those paths here in a minute. We're going to call those chains, IP tables chains. And then we're going to go through the steps to create a firewall or a router policy, basically any policy that we want to be able to control what goes on, packet flow control. We're going to go through the plain text objectives, and it says stubby pencil and piece of paper. This is one that you can sketch out, draw out, and kind of draw the paths, what goes on. I'm going to do it a little bit in an automated with a PowerPoint, but you can go through this with a pencil and piece of paper and see what you want to allow in, what you want to allow out. Then we'll look at what the ports are. After that, the permit and deny objective, because we're going to set a policy, and the policy can be one of two things. We can either let everything in or let nothing in. Once we set the policy, then we control the exceptions to the policy. After that, we'll look at a table of services and ports. Services obviously are related to ports, ports related to services in the TCP world. And then we're going to look at some tools to assist with the IP table syntax, and we'll write the IP table script. The IP table syntax is pretty consistent. A couple of tools, and what I'm going to look at is called FW tables. There are a number of websites that are available to help you write the script. And basically, once you get the first rule written, you should be able to emulate it and write the rest of your rules. So we're going to look at this thing we have in here. We're going to have three different chains. We're going to have the input chain, which goes to the local process, goes to the computer itself. If we were trying to telnet to the computer, SSH to the computer, go to a web page on the computer, that would be an input chain, something that goes to a resource that's on the firewall machine itself. Then we have the output chain. The output chain is something that comes from the firewall machine, the computer that it's running on, because a firewall is nothing more than a computer, regardless of whether it's a Linux machine run firewall script, whether it's a Cisco firewall. Any of those are computers. Some of them have more specialization than others. So this is something that comes from the machine. This might be something like a proxy server, for instance. And if you had a proxy server, obviously you're going to have to allow access to and access from. Generally, in the policies, you probably want to set the policy up that you don't let anybody connect to your computer unless you actually allow it to go from the computer. You probably, or from the firewall, you probably don't really care, so you may want it to be in a permit sort of arrangement. The last one, and the one that we're most concerned with, is the forward chain. The forward chain is actually IP forwarding. It goes across, things that go across or through the machine, and we filter the processes as we go through, or the processes, the services as we go through. So we start here, we go into the pre-routing NAT, and into the route. The route can we either go to the input chain or we go to the forward chain. And in this case, we're going to go to the forward chain, and we're going to bypass all the local processes and come out in a post-routing chain. And from there, we go to the local area network. This shows internet, home network, could be private network, DMZ, could be internet, DMZ, internet, DMZ, private network. Any of those are possibilities here, depending on how we have the thing configured. And we have Ethernet 0 and Ethernet 1, the NICs that are attached to the machine. Notice that we're not controlling access to the NIC per se, but we're controlling access to the chains that either get us to processes on the computer, take us from processes on the computer or get us around the local processes and filter the packets as they go through the machine. This is all of it put together. We have the input, the output, and the forward chains. The forward chain policy we want to look at, it's going to go through a step-by-step what we would do in plain language. So the first thing we want to do is set a firewall policy, and you notice we got these little do not enter signs that popped up. What we're saying is we're going to set the firewall policy to deny all traffic in the forward chain in either direction. Once we have established the policy, then we can make exceptions to the policy. The first thing is to establish what you're going to do, and again, basically you can have either something that permits everything or something that permits nothing. And I would guess, unless you really don't want to work there very long, you probably want to set your policies to deny all traffic, because then you can allow specific services, specific machines through the firewall. The next thing that we want to do, and we've got this line here now, we're going to poke holes in the firewall, because we said nothing can come in and nothing can go out. Now we're going to poke some holes. So the first thing we're going to do is let the private network, the one over here that we're on that has our machines on it, the 192.168.100 network, get to the DMZ resources. And in the DMZ we have a Linux server, an email server, and a web server. We've got the company web server sitting out here. We want our users to be able to get to resources there. Email server sitting out here, so we want them to be able to get to their email. A proxy server is here, which will be used for access to the internet. So then we want them to be able to get to that proxy server. So we're going to allow access to the proxy server. We're going to allow access to the mail server. We're going to allow access to the web server. After we have access to each of those resources, we want to allow the answer back to the requesting source. If I want to go to www.yahoo.com and I go to the proxy server goes to the internet and gets that web page for me. It would really be nice if it were able to deliver it back to me. So we're going to have to allow the answers to come back also. So again, policy is going to be to deny everything, and down here below we have the picture of what we just did on the firewall policy. So we're going to permit the protected network 192.168.100 with a 22-bit subnet mask, and if you look at that, it's 100, 101, 102, and 103. That is a network that can be supernetted, so we could allow all of those resources out, all of the subnets out with a single statement to permit the protected network. And then we're going to allow access to the proxy server. In this case we have a SQUID, a Linux proxy server. It's going to be in port 3128. We're going to allow access to the web server, port 80. And port 443 we have HTTP and HTTPS. And we're going to allow access to the mail server. If we're using a client, port 25, port 110, perhaps maybe we're going to use port 143. We also might want to consider port 443 to allow an HTTPS connection to a web mail service. And again, we're going to let the answers back in, and that's going to be a single statement, established or related traffic. Established says that if we initiated the connection, let the answer back in. The sample policy services here, a little table of just a couple of things. One, HTTP, the protocol HTTP. The source is the protected network. We're going to let our private network, protected network, and the source ports any, and I say greater than 1023 because 1023 and below are reserved ports. And the destination is going to be the web server. The destination port is TCP port 80. We also, as a second one, protocol HTTP from the protected network, any source port going to the proxy server, port TCP 3128. Again, the things that we have already done earlier. Now we're going to address the ports and the IP addresses. So HTTP is, again, the protocol. The source is the 192.168 200.100.0 network with a 22-bit subnet mask. The source port any, or we could say greater than 1023, and the destination is now going to be the IP address of the resource that has, in this case, port 80 has the web server on it. So it's going to be 200.100.100.13, and the destination port will be port 80, our HTTP port. We also could put in there HTTP and HTTPS. We could put port 443. This is not an all-inclusive example, just going through the steps of how we would actually configure the firewall policy. The other one, HTTP, again the source is the same, the private network 192.168.100.0, 22-bit subnet mask. The source port would be any, the destination, in this case 200.100.100.14, and the destination port is going to be TCP 3128, the listening port for the SQUID proxy. So we'll look at a couple of tools here, or tools that can assist you with the script. There are lots of websites out there. If you just go and search for an IP tables builder, there are a number of websites that will write IP table scripts for you. Commands follow the same sequence, and if you've done the exercise, IP tables and the protocol, what we're going to do, and we'll look at that when we do the little help. The Linux Home has good explanations and examples. www.linuxhomenetworking.com. Chapter 14 is the one that explicitly covers IP tables. There are a number of standalone applications that will do that. The one that I'm going to use to go through how we do these things is one called FW Builder. You can get a 30-day demo from them, and then write a demo, and then I'm going to write a demo script to show you how to do it. We're going to go through, I'll show you the objects that you need to use in FW Builder, how you apply your policy, and then how you can use it to get the specifics for an IP tables script. Okay, what I have here is a piece of software called Firewall Builder. This is version 4.0. The versions keep changing, and what you can do with them, sometimes good, sometimes bad, it increases. It has a couple of kind of interesting aspects. We have the user here, and we'll go ahead and just start some of these things. When I want to create a firewall, click on New Firewall, name the firewall, let's call it Demo, something really clever. And then we choose the firewall software. This one is defaulted to IP tables running on Linux 2.4, 2.6. If you go into the drop down, notice that it has other software that are available, including Cisco. So you can write your Cisco iOS access control list, your PIX access control list. So you can do Cisco control lists using this software. IP filter, IP firewall. We'll stick with the IP tables. Next, the first thing we need to do is configure our interfaces, and I'm going to say configure them manually. We're going to click the plus sign, name the interface, let's call them ETH0. ETH0. Typically that's going to be the outside interface. O or 0 looks like O for outside, just to keep things straight. And on this one, since it's the firewall, we'll say it's 200.100.100.1 with a subnet mask of 255.255.255.0. Then we're going to add the second interface, the inside interface, the one that would face our protected network, our private network, and we'll call it inside. Inside, and its address 192.168.100.1, and it will be 255.255.252.0. Finish. And we have our interfaces, and we'll be able to create a policy here. Before we do that, I want to create a couple of objects, and we'll create the objects first for the network, new network, and the new network would be our private, or let's call it our protected, PROTECTED, which is 192.168.100.0 network with a 255.255.252.0 address. So we've created that resource. The other thing that we want to do is create some hosts. New host, and let's say the first one is the web server. And we can either use pre-configured or we can just go ahead and manually create these things. You notice that if you're using this on a network, it does have SNMP capability to discover. As long as everything has SNMP configured and you have a community string that you know that you can actually have this thing find things. But we'll do it manually, and we'll call the interface ETH0 on this thing. The label will be the DMZ interface, and it was 200.100.100.13, I believe, with a 255.255.255.0 subnet mask. Right now I'm going to pause and go ahead and make a couple of other objects. You get the idea of how you configure these things, so you can make objects to represent the resources that you're going to control. Okay, we made a couple of resources. Actually, I only made one other, which was the proxy server. So we have the protected network, which is a defined range of IP addresses, and then we have the web server and the proxy server, which are on explicit IP addresses, and we have the two Ethernet ports, ETH0 and ETH1, that are on the firewall machine itself. When we want to create a policy, we can right-click on Policy, Edit, and we get a white area over here, and again right-click and we can insert a rule. Well, our first rule probably would want to be one where we allow all the answers back. That's something that you probably are going to want to put at the top end of your script, because the scripts, the access control lists, go from top to bottom, so you want to have the things that are used the most frequently at the top of the list. One of the things that they did with Firewall Builder, we have in this drop down up here at the top a user as well as a standard. The standard services are already defined for us. So if we go into TCP, we get a whole list of things, and down here we include HTTP, HTTPS, and if we go on down to the S's, you should find SQUID here defined. So the ports are already associated with services. The first thing that we want to do again is the established. So the source would be any, destination would be any, the interface would be all. Just drag over here the service established, and we're going to accept. Everything comes up as a deny initially. So we're going to come up and accept those things. We have other options, and then the times we can configure time. The interface can be the inside interface or the outside interface, but the established, we're going to just leave it there and allow things to go in both directions. The other thing that we can do, we'll look at real quickly here before we actually define a rule. Well, actually, let's go ahead and define a rule. Let's go back to user. The next thing that we want to do is to add a rule at the bottom. We're going to allow our protected network, it's going to be the source, to go to the web server, and the services, now we can go into the standard services. The services that we want to allow are perhaps HTTP and HTTPS, and the interface that we're going to allow that on, go back to our user here, the interface we're going to allow on ETH1, our inside interface. So we drop it in there, and it's going to be in an inbound direction, inbound to the inside interface, and this is going to be an accept. This is how you would do that. I'm not going to go through how you would put each of the services on this thing. Next thing we would want to do is, how do we get our script information out of here? If we right click on a rule, we can compile the rule, and this one, this piece of software, for whatever reason, decided that they needed to have a variable for IP tables. You don't necessarily need that. IP tables will work on the smooth wall firewalls that we're using. So just IP tables, and with just the -n says to do a new rule 0. We don't really need that. What we need is what we're doing here. This says IP tables -a. We're going to add to the output chain -m, modify the state dash dash state established and related dash J rule 0, which comes down here and says accept. So we can use here IP tables dash A output dash M state dash dash state established and related dash J accept. The same thing for the input and the forward chain. What this does is allows the answers to come back. That was the first thing we talked about, one of the earlier things that we talked about, top of the list, to allow the established communications to come back, to allow the answers to come back to the questions that we asked. To look at the web server quickly, we can right click on it again and compile the rule. Again, makes a new rule, uses the variables to go through what we actually need, does the logging, which we would do in real life. Right now for what we're doing, we don't really have logging configured, so we're not going to log at this moment. And then down here, the action for the new rule that it established. What we need again here is IP tables, lowercase, dash A, add, in the forward chain, dash I, the input, ETH1, our inside interface, dash P, the protocol that we're using is TCP, dash M, we're matching TCP, dash M multiport allows us to use more than a single port. And over here we're going to see D ports 80 and 443. If we didn't call the multiport, we would not be able to put more than one port at a time on the line. So dash multiport, the dash S, the source of the packets is 192.168.100.0 with a 22-bit subnet mask. The destination is 200.100.100.13, and the destination ports again are 80 and 443. Dash M state, we're going to match the state. Dash dash state is new because this is a new connection. The rule that we did before was established and related to allow the answers back in. And dash J, and we're going to accept. Instead of writing the 4 statements here to do one line, we're just going to use the single line. You do that for each of the services, and if you go through this thing one service, one interface, one computer, one at a time, it's something that's manageable. If you look at it and try to do everything at the same time, it becomes an overwhelming task. Again, this is a tool that I think can help in writing the script itself. It's not going to write the firewall, it's not going to think through the firewall for you, but it allows you to visualize what goes on. Let's do one other one here for the proxy server. It's against the same thing, isn't it? We're going to allow our protected network. Actually, we've got to do a new rule. We're going to add a rule to the bottom. We're going to add our protected network, and we're going to have the destination here will be the proxy server. And the service that we're going to use, again, we'll go back to the standard services and go on down to Squid. And once you get these things written, you can go in and change, when you write the script itself, you can change the port number, Squid, so that if we had like maybe a proxy plus that uses port 4480 instead of using 3128, we would use 4480. The interface that we're going to do this on, go back to our user. Again, it's going to be ETH1, our inside interface. It's going to be inbound, and we're going to accept it. We can limit times here if you want to, if you want to limit time down here. Find input, output, the editor, any interval you can specify time. If we go in here and again compile the rule, it says IP tables dash A in the forward chain. The input ETH1, the protocol's TCP, the source again is our private network 200.168.100.0. We defined it once. Going to go to 200.100.100. It says 17. That's because I typed it in wrong. The destination port's 3128-M state new, and it'll be dash J would be accept. Since I did type that in wrong, what if we typed one of these things in wrong, which I did? We'll go back here, ETH, go to the IP address, edit, and it was, I think this one was 14, and it's going to then, if we go back and compile the rule, it will change the address. It's changed the address to 14 from 17. So it's just a matter of going back in and getting it sorted out, rerunning the rules so that we can see them. It's a quick and dirty on how to configure the FW. Okay, right now we're on a virtual smooth wall firewall machine at the command prompt. The way that we configure the firewall scripts is through a text editor called VI editor, which is a little different if you haven't used it. To get into it, just type VI. After we click into it, VI enter, and we get this advice. And one of the more helpful things here is to type Q enter to exit, and colon Q, and then the enter key to exit, colon Q W to write the command. In order to start typing, you have to use the insert key, and you get the insert in the bottom left hand corner, and then we can start typing our script. Instead of going through the entire script, what I'm going to do is to open an existing script. To get out of this thing, use the escape key to get rid of the insert. Get the colon Q, and you notice it says that there's been no write. Use the override. Use exclamation to override. So Q exclamation point gets me back to the command line. I'm going to use the clear command, and I'm going to VI. And if you want to name the file when you start it, VI and then the name of the file. I call mine Firewall. Does some things that we talked about in the how do we get to the point that we want to write the script. I've defined a couple of variables at the top, which is probably a good idea if you're going to use it on multiple machines, or if you're going to use it in an area that your interfaces may change. What I've defined here as the inside would be the name of the interface, ETH1, and the outside, ETH0. Remember, though, that if you do this, you will have to define the variables so that you can use these. Again, good idea if you're using it multiple locations. The next thing, iptables-F is going to flush the existing tables. What we don't want to do is to append or to merge our firewall script with any existing scripts. We want them to go away and our script to be the one that actually is applied. The -X and the -Z clear out any new rules that may have been written. The iptables-T NAT table NAT-F flushes the NAT table. The next thing we do, iptables-P sets the policy. The input policy coming to our machine is a drop. The output is accept, and the forward is drop. The echo1 /proc sysnet IPv4 IP_forward turns on IP forwarding, which allows us to forward the packets across the machine. If we don't turn this on, there's no IP forwarding. The packets go nowhere. The next statements, iptables-A forward output input -M state -state established and related -J accept are the ones that are going to allow the answers to come back, the established and related traffic that we talked about. After that, iptables- the specific command that allows us to that allows the web services to go from the private network to the web server that's in the DMZ is the one down here, iptables-A /I ETH1-P. Protocols TCP. We're going to match multi-ports. The multi-ports are 80 and 443. The source address 192.168.1.0 with a 24-bit subnet mask in this case. And again, whatever our protected network is would go in here. The destination, whatever the destination IP address is of the service, in this case it's 200.100.100.10. -M state -state new allows us to establish a new connection -J accept. What you would do now is to put a statement like this for each of the actions that you want this firewall to perform. If we had 4 different services that we want to allow out, we would need the 4 different services to do there. ICMP, whatever you want to happen with ICMP, whether you want to allow responses, allow pings out, the different things, and take a look at ICMP. It has an awful lot of flags that are available. a number of things that you can do here, but that is the basic process, the procedure for writing an IP tables firewall script. This has kind of been a long how-to. I hope it's been useful, and thank you for watching.